Despite its exceptional nutrient density and unique glycemic profile, Helianthus tuberosus, known globally as the Jerusalem Artichoke or the Sunroot, remains a marginalized player in a global dietary market projected to exceed $200 billion by the end of the decade. Its absence from the mainstream grocery aisle isn't a mystery of biological failure, but a complex result of logistics, lack of supply chain standardization, and regulatory hurdles that often sideline local food systems in favor of global commodities. To the industrial eye, it is an invasive nuisance. To the seeker of nutritional sovereignty, it is a biological masterpiece waiting to be reclaimed. Deep within the records of nature's forbidden cache sits a plant that perfectly exemplifies the gap between biological potential and economic reality. Helianthus tuberosus, commonly known as the Jerusalem Artichoke or Sunroot. Despite its exceptional nutrient density and resilience, it remains a niche player in a global market that favors standardization over local diversity. Its absence from the mainstream grocery aisle is not a mystery of nature, but a complex result of an industrial machinery that sidelines local food systems in favor of global commodities. The story of the Sunroot's exclusion is a byproduct of economic priorities. During the colonial era and the subsequent industrialization of agriculture, programs were heavily tilted toward cash crops designed for export, such as cotton, sugar, and wheat. These crops were the engines of revenue, requiring a synchronized system of high-yielding varieties, expanded irrigation, and synthetic inputs. Local food plants like the Jerusalem artichoke, which grew along fence lines and in backyards, were rarely integrated into formal agrarian policies. This led to a bifurcated system where a vast library of nutritional knowledge was left to survive only in the informal margins of rural life. Biologically, the plant is a masterpiece of resilience. It is a survivor, adapted to thrive in marginal soils where more delicate commercialized crops would fail. Under optimal conditions, its stalks can reach staggering heights, capturing solar energy with a speed few other temperate plants can match. However, this very strength is what made it an economic nightmare for big agriculture. Because it is a perennial that spreads via a persistent underground rhizome system, a single planting can provide a stable food source for decades without ever needing a new bag of patented seeds or chemical fertilizers. In an economic landscape built on scale, uniformity, and purchased inputs, a plant that thrives on neglect and replants itself indefinitely simply does not fit the prevailing business models. Historically, the marginalization of the sunroot was further cemented by social labels. In many regions, plants that were not part of the commercial economy were branded as famine foods. This term was born from social associations. If a plant was eaten primarily by the poor or during times of crop failure, it carried a stigma that deterred its use in modern diets. This cultural bias ensured that scientific priorities followed the largest markets and funding streams, leaving the Jerusalem artichoke under-researched for much of the 20th century. It wasn't a cold, calculated conspiracy to erase the plant, but rather the mechanical indifference of a global market that values standardization. The industrial system prioritized crops optimized for transportability and yield, often at the expense of the dense, diverse nutrients found in species like the sunroot. By the mid-20th century, as landscapes were cleared for vast rows of soy and wheat, this vegetable that walks was relegated to the botanical blacklist. It has spent decades waiting for a world that is finally beginning to realize that nutritional security cannot be built on a handful of global crops alone. The mid-20th century marked a pivotal transformation in the history of global agriculture, a period widely recognized as the Green Revolution. This era was defined by a massive, synchronized effort to increase the yields of a select group of staple crops, primarily wheat, rice, and maize. The global food system achieved unprecedented levels of caloric production, but this focus on a few key staples led to a structural shift in agricultural priorities. It left many traditional and multi-purpose species, such as the Jerusalem artichoke, in a state of relative neglect. While the world successfully increased its caloric output, the Green Revolution unintentionally shifted the human diet away from the dense, diverse nutrients found in ancient roots toward a narrower range of industrial commodities. To understand why the Jerusalem artichoke was sidelined, we must look at its internal software, the way it stores the solar energy it captures. Most modern staples like the potato or white rice are optimized to store energy as starch. Starch is a simple chain of glucose molecules that the human body can break down almost instantly. From an industrial perspective, starch is perfect. It is stable, easy to process, and provides a quick caloric hit that fuels the modern workforce. However, the Jerusalem artichoke operates on a completely different biological logic. Instead of starch, it utilizes a complex carbohydrate called inulin. Inulin is a polydispersed carbohydrate consisting mainly of fructose units. From a metabolic standpoint, inulin is a masterpiece of biological engineering. Unlike starch, it cannot be broken down by human digestive enzymes in the upper gastrointestinal tract. This means it passes through the stomach and small intestine without causing the rapid blood sugar spikes and insulin surges associated with industrial carbohydrates. It acts as a metabolic bypass, providing sustained energy and supporting health in a way that modern commercial crops simply cannot replicate. For a world currently facing an epidemic of metabolic dysfunction and diet-related diseases, this ancient carbohydrate structure is a critical, yet ignored, resource. As the inulin reaches the large intestine, it reveals its true purpose. It is a powerful prebiotic. It serves as a selective fuel source for the gut microbiome, specifically stimulating the growth of beneficial bacteria like bifidobacteria. In the hidden ledger of nature, the Jerusalem artichoke isn't just a vegetable. It is a sophisticated delivery system for gut health. Modern pharmaceutical research often focuses on isolating specific prebiotic compounds for synthetic supplements, but nutrition science is increasingly realizing that the synergy within the whole food matrix of the sunroot offers benefits that isolated powders cannot match. This isn't a rejection of laboratory science, but a maturation of it, an acknowledgement that the complexity of a species shaped by millions of years of evolution is a technology in its own right. However, this metabolic brilliance is precisely what made the plant a logistical nightmare for the global market. While starch is chemically stable and allows potatoes to be stored in massive climate-controlled silos for months, inulin is dynamic and fragile. Almost immediately after the Jerusalem artichoke is harvested, its inulin begins to break down into simple fructose. This process causes the tubers to lose their firm texture and nutritional bypass qualities relatively quickly. For an industrial supply chain that demands months of shelf life and cross-continental transportability, the sunroot was too alive to be easily managed. The world chose the shelf stability of starch over the biological efficiency of inulin. Furthermore, the relative neglect by the industrial system did not lead to the plant's disappearance, but rather its preservation in the informal margins of traditional knowledge. As the limits of agricultural systems built around a narrow set of species become more apparent, the focus is slowly returning to these underutilized crops. The transition we are seeing today is not about a war between nature and industry, but a realization that long-term nutritional security requires a more diverse and resilient botanical portfolio. The Jerusalem artichoke has spent decades waiting for a world that is finally beginning to realize that caloric quantity is not a substitute for nutritional complexity. In recent decades, rising rates of diet-related diseases and increasing climate stress have prompted a renewed and rigorous scientific scrutiny of global food systems. The era of focusing exclusively on caloric output is beginning to yield to a more complex understanding of nutritional density and ecological stability. Within this shift, the Jerusalem artichoke has moved from the peripheral botanical blacklist of neglected species into a central subject of modern analytical research. This transition isn't a defeat of the industrial model, but a critical recognition of its limits, and an acknowledgement that long-term food security requires a more diversified botanical portfolio. Modern analytical methods have helped characterize the nutritional and phytochemical profile of the sunroot with unprecedented precision. The modern research paradigm is also evolving in how it views the delivery of these nutrients. While pharmaceutical research often focuses on isolating specific compounds for synthetic replication, nutrition science is increasingly studying whole food matrices. There is a growing understanding that the synergy between the vitamins, minerals, and complex inulin fibers within the Jerusalem artichoke tuber may offer benefits that isolated supplements cannot match. This isn't a rejection of laboratory science, but a maturation of it, a realization that the complexity of a biologically efficient species, shaped by long-term ecological pressures, is a sophisticated technology in its own right. Crucially, as agronomists look closer at the plant's role in the ecosystem, they are correcting long-held misconceptions about its biology. For decades, industrial farming labeled the Jerusalem artichoke as a hostile invasive due to its persistence and ability to overtake commercial monocultures. However, scientific data confirms that its contribution to soil health is both mechanical and organic. Through its deep rooting system and the consistent contribution of organic matter via leaf litter, the sunroot improves soil structure and nutrient cycling. It is a primary example of evolutionary adaptation to harsh environments, thriving not by creating resources, but by being exceptionally efficient with the resources available in the margins. This biological efficiency extends to the plant's role in ecological restoration. While modern monocultures require constant human intervention and chemical support to survive, the Jerusalem artichoke flourishes in marginal soils and extreme temperatures. It serves as a biological insurance policy for food security in a changing world, thriving where more fragile systems are beginning to struggle. This relative neglect by the industrial system did not lead to the plant's disappearance, but rather its preservation in the informal, forbidden cache of local communities and small-scale farmers who understood its value long before the laboratory caught up. International organizations have increasingly referenced these underutilized crops in discussions of dietary diversity and local nutrition strategies. The Jerusalem artichoke is no longer viewed as a famine food, but as a resilient, locally accessible resource that can support nutritional intake in vulnerable populations. The integration of these species into global conversations reflects a broader shift toward diversified food systems, where the resilience of underutilized crops complements the strengths of modern agriculture. The transition is not about a war between nature and industry, but a realization that long-term nutritional and climatic security requires a more diverse and resilient botanical portfolio. The story of the Jerusalem artichoke concludes not with an overthrow of the system, but with a necessary integration. The renewed interest in this species reflects a world that is learning to value biological diversity as a pillar of survival. As we move forward, the forbidden cache is being opened, not to replace the progress we have made, but to ensure that our future is built on a foundation of ecological resilience and nutritional density that can withstand the pressures of a changing planet. The reevaluation of the Jerusalem artichoke is a testament to the power of scientific curiosity over institutional habit. By integrating the hard-won resilience of this species into our modern food systems, we are not just growing a tuber. We are cultivating a more stable and diverse future for global nutrition. The sunroot is more than a plant. It is a biological choice. By opening this file, you have chosen complexity over industrial habit. Reclaim your biological independence. Subscribe to the Ancient Roots Vault to uncover the technologies nature has hidden in plain sight. The vault is closing. Stay resilient.